Hello, and welcome to this new AdonisFX 2.0 tutorial in Houdini. My name is Lucas Ferry. I'm an R&D engineer here at Inbibo, and I'm going to be presenting you with the hybrid workflow. And the characteristics of this workflow is that you may not want to actually model each and every single muscle. You have already a quite compelling skin cluster inside of Houdini, for example, and you just want to add some secondary dynamics and some sliding to the final results. So what we're going to do here is we are going to actually create procedurally a fascia layer, and then we are going to actually simulate the fat on top and then a skin layer with sliding to add some secondary dynamics to the character without the need to model each and every single muscle like we had in our crafted workflow. So what we want to achieve with the hybrid workflow is the following. So on the hyena, you will be able to see that we want to add some dynamics overall to the whole character, especially in the neck area. And then, as you can see right here, that's sliding over the underlying geometry. And we are going to be achieving this by layering a procedural generated fascia that is animated with a fat layer on top, and then a skin simulation with sliding on top to enhance the results of your non-hero characters. So in this scene, you will find the following setup. If we go inside of the geometry subnetwork, you can find these settings that you see right here. So actually, let me come to smooth shaded. So the entry points are the skinned geos, which in this case is pointing to an FBX that will be packaged with this file. Then we have the walk animation and we have a trotting animation, which can be switched with this switch right here. And yeah, here we are doing some creations of path attributes. This is mostly also for the crafted workflow. But what we're interested in is to actually have the mesh deformed. And very important here in this node right here, we have created an original point number, which will be used to then drive the animation of the cutout geometry. Everything else is more strictly related to the crafted workflow to actually create a unique path attribute to split the geometries. So here we have the animated skin. Coming to the next section, so I've prepared here some node nodes that we're going to use to populate this workflow. We have here an object merge that brings in the animated skin, and we have the following setup. So we have here the animated skin, the full animated skin. Then we have a cutout for the fascia, which we're going to configure. Then the same for the fat, the skin sim, and then we finally have the rendered skin, which is time shifted to the start frame. And this is essentially what we're going to use our ADN skin merge node on to actually bring fuse the results of the simulation with the actual animation. Great. So as you can see here, we have this isolate body subnetwork, and this one is in charge of actually splitting the geometry. So to actually isolate the body from everything else. So the first thing that we are doing, we are time shifting. Then we have here an attribute wrangle, which just sets the original ID. Let me rename this quickly. Set ID. And then we have here a group node that I'm going to explain in a second. So let me save this scene out. And what we have done right here is we have selected the seams of this character. And actually, let me put this back to the wire shaded. So we have selected here the UV seams. So not the UV seams, but the seams of where we want to cut out the geometry. So we want to avoid, for example, the paws, we want to avoid the tail, and we also want to avoid the head of the character. So we created a group on edges, and then we use the connectivity node with the connectivity type set to primitive, attribute set to the island that we have created before. And here we are, so this is essentially the one that we are going to create. And here we are using the seam group to actually tell where to actually cut the different portions. So if we now come here and check out the attributes, we check here the island, you can see that you have several pieces. So we have piece 0, 1, 2, 3, 4, 5, 6. So in this case, we want to keep just piece 3. So here in the blast node, we set the group type to island piece 3 and we delete non-selected. So now we have a clean version of this mesh that we can then use to model our fascia, fat, and skin. Great. So let's start off with actually creating our fascia. And for that, we have a node that's called ADN push. And we want to place it in between of these two null nodes just to make sure that the output is the one that's going to be affected by the simulation and the input is the one that is non-deformed. And that's important for when we want to transfer data between different DCCs. Great. So here we on this node, we have something called push length. And then we set this to a value of -2, for example. What it will do, it will shrink that fascia geometry along the normals, and yeah, it will push it inside and we will be able to see exactly what's going on. So actually, if we, for example, come here, create a merge node and use a clip node right here, you can see that here we are pushing this geometry inside, and that's essentially what we want. But yeah, I can just bypass this right now. In some cases, we may have like these artifacts here which we want to smoothen out. So here we come to the AdonisFX menu, and we can come here to make paintable option. So it's just a utility that eases the different paintable parameters that we have on the ADN push node. So here, if we now come to the push multiplier, what we can do is we can, for example, cook the push and enter the viewer state of the paintable, sorry, the attribute paint node. And what we're going to do is we're just going to use a value of 0.5, and we are just going to flood the mesh. And for reference, the one that is going to be deformed is the one that you have below. So in this case, we may want to, not push in the geometry all too much in this area right here. So what we're going to do is we're going to set, for example, to a value of 0.1, the mesh in this area. And yeah, depending on what you want, you can also use the mirroring. It really depends on how well it will mirror the geometry, but then I'm going to show you a quick trick then later on to be able to mirror the weights properly. So for example, here we can set this to this value. If we zoom into this area, yeah, we may also want to preserve here further and not push in this geometry all too much. And let's not use a value of 0 because we still need to keep a small gap for the fat layer to create the divisions. And yeah, in some cases we also may want to change in different areas the weights. So for example, let's use a value of 1 on the belly area, because there we essentially want to create quite some jiggle. So something like this. Could go even further up here. And yeah, we may also want to not push in too much here the geometry, so we could go with a value of 0.7, for example, in this area right here. And yeah, we also probably want to do something here in this area. And then in this area right here, we also want to avoid painting it on the landmarks, because they are really the ones that we do not really want to push things in. So here, this looks good. And yeah, do the same thing for the knees here. So maybe something like that. And yeah, as you can see here, with some smoothing, we may be able to reduce a bit better this area. And yeah, actually let me, so here I had a value, let's use a value of 0.3 actually in this area, which is essentially what we want. We want to have the inverse effect, not what I painted before. So here, this, like this. Great. So I don't think I'm missing anything. Yeah, we also may want to not push in this area all too much. So let's say that we want to use a value of 0.1 here. And yeah, and then we can go ahead and we can just flood this quite a bit like this, and we can check out the results. So come out of the viewer state, and as you can see, in some cases we may have this kind of pinching effect, but that's something that we are going to fix in a second with our relax node. Okay, so as you can see right now, nothing is happening, so we are not animating anything. And the reason for that is that we have to actually apply the animation to this stream of data. So before doing anything, what we're going to do is we're going to drop down an attribute copy node. And given that I've created that unique ID, I'm going to bring over the full animated skin. I'm going to use the P attribute. And then what I'm going to use is I'm going to match by attribute, and I'm going to match it by ID. So now you can see that we have this animated, which is essentially what we want. And then we have the push below, which allows us to see the results. Great. So that would be kind of our fascia. And now what we can do is that in some areas we have, not such great results from the push, and that's just because it's pushing inward, so we actually have to relax some of these areas, which is to be expected. So we can bring this over here. We can also make this paintable, and in a second I'm just going to show you another trick that you can use to speed up your scenes. So in this case, we are interested in painting not the smooth multiplier, but the weights. And in this case, we are going to flood everything to 0. So in this case, yeah, that will allow us to just pinpoint the areas that we want to relax the mesh. So let's do that. Let's set everything to 0. And going to the settings of the node, let's use 20 iterations, for example. Let's use the pin option to pin the border regions. And yeah, as you can see now, nothing is happening because we had painted the weights. If we remove this, you would see something like this, similar. But we are removing a lot of those details from the original skin. So that's something that we do not want. So in this case, as before, I'm going to come into the viewer state, and I'm going to start painting the areas that I want to relax. So in this case, let's use, for example, a value of 1 here to relax all of this region over here. And I'm going to show you a quick trick where I'm just going to paint one of the regions, and then I'm going to mirror the weights over to the other side. And yeah, so here, for example, in this area, and let's make sure to not relax the insertions, so the landmarks, because we do not really want to relax like this bony area right here. So in this case here, you can relax all of this area here and here. And in some cases we may want to avoid kind of like a candy wrapping effect happening on this area, so we may want to just use a value 0.2 in this area. As I said before, you can use the symmetry option, But what I'm going to show you quickly is a way to mirror this and speed up the process. So something like this. And yeah, let's see, maybe some areas of the belly. So here in this area, we may also want to relax to avoid creases, especially in this area right here. So something like that. And yeah, we can then just give it a quite some smoothing. And now what I wanted to show you is that, okay, now we have the relaxation happening on one side. See how that looks. Yeah, it's quite good. But as you can see on the other side, we still have this, yeah, these artifacts. So what I'm going to do is I'm going to also come back to the original attribute create and attribute paint. We're going to move this to the side also for push. Going to drop down attribute copy node, and we can just plug this in here. Well, actually this one in here and this one in second input. We're going to copy over the points. Sorry, not the points, the paintable attributes. And we are going to actually drop down a time shift node, $ at the start, drop that down in here. And yeah, now this stream of data is time independent. We are just going to copy this over at each frame per se. There's probably better ways of doing this, just getting the original geometry. We already have like an attribute copy here, so we may be able to, yeah, ingest this data upstream further, but I'm going to leave it just like this, just so you know that you can speed up the process like that. And then we have here an attribute mirror. And let me bring this down a bit. Can remove these nodes. And here we're going to just mirror the weights that we have painted. So here the group type is points, and attribute to copy is we're going to use the push multiplier to mirror the weights. So if we come here and now check out the push multiplier, you will see that, yeah, we did a quite good job with the painting, so it shouldn't do much because we did the painting correctly, but this will really help down below. So we're going to do this exact same thing here. So we're going to reuse this time shift, place it in here. Then we are going to bring here the mirroring. And finally, we're also going to do here an attribute copy. Bring this in here. And here we want to, instead of using the push multiplier, we want to use the weights. Great. So let's see, now visualize this. So here we have the weights coming in. Okay. And yeah, let me see, because we have to maybe change this a little bit to be able to pick up the right values. So here we have the plane. So the origin and the direction should be, let's see, so the x-axis is correct. So here we have the weights, which makes sense. That's exactly what we have painted. And here we have the attribute mirror. And yeah, we want same as source. Great. And so here we have the origin, here we have the distance. Okay, and yeah, essentially what we want to achieve is that the values to copy are mirrored to the other side. So in this case, I guess it should be a distance of -1. And yeah, because we have this on this axis right here. And as you can see now, the weights are mirrored to the other side. And that gets copied onto the original stream of data. And that's what's going to be then used to relax also the other side. So now in theory, if I play this back, you should see that the other region of this character also has, yeah, correct deformation, and it's running faster than before because we have applied these changes right here. Great. So now we have prepared the fascia. We can then always go back and see if there's any other candy wrapping effect. So for example, here, I'm pretty sure that we have to fix this area here too. So we can come here to the attribute paint node in this case, and let's see if we can paint this area too to have some relaxation. So in this case, let's use a value of 0.7, for example. And in this case, I'm just going to use the symmetry option. Well, actually, we can do the same exact thing as we did before. So here, then the mirroring will apply to the side. And let's see now. This is relaxing better. Yes, it looks like this looks a lot better now. And let's have a look at all of the other deformations to see if there's anything else that may be an issue. And it looks like everything is pretty clean. But anyways, later on we will do another pass in which we will refine this whole setup. Great. And yeah, now that we have created the fascia, I'm going to jump onto actually preparing the fat layer. So now it's time to actually configure the fat layer, which would be the next layer to configure. We had configured this fascia, which is pushed in compared to the actual fat, which is going to be surrounding this area. We could, of course, then, increase even further the gap between the geometries, but yeah, I think for the time being, this should work pretty nicely. So now what we're going to do is we're going to bring this null node down here because we want it to be affecting in between. So we are going to use an ADN fat node here, place it into the geometry, which is static, as you can see right here. And we are going to use as second input the fascia that we have just created. Bear in mind that they have to have the same topology, so please do not remesh anything here because it will not work when applying ADN fat. Great, so straight the box we can reduce a bit the substeps and the iterations. And essentially what this should allow us is to have a faster simulation. And we can already see all of those dynamics happening on the belly. So if we compare it against just, let me put this in real time. So you see there, this is quite static. You can't really appreciate the dynamics, but if we use our ADN fat solver, you can see how the skin is stretching, compressing, and also jiggling. So that should be it for actually just configuring the fats. We can also temporarily use a different stiffness multiplier just to make sure that we get more dynamics out of the system. Some cases may be too much, but yeah, for the time being, I think we can live with just setting the stiffness multiplier to 1, and yeah, we can then play around with the different parameters later on. Great, so ADN fat was quite straightforward to configure, but as you may have noticed, we haven't added any sliding to the actual mix, which is something that you may want to achieve. So for that, we are going to come here onto the cutout skin. Let me bring this down here, and we are going to create an ADN skin solver. Drop it down here, and we are going to create one target mesh. So here, use the one that has the out prefix. So drag this in here, and this should already have ADN skin configured, but we actually need to configure the painting. So straight out the box, what will happen is that just hard constraints will be configured, but that's essentially something that we do not want because we want to kind of give it like a springy behavior to the skin. So what we're going to do is we are going to come here again and make this paintable. And we can bring this all the way down here. And now what we can do is we can start painting the maps. So one thing that we also do when we do the make paintable utility is that we define the the defaults of the weights in this way. So in this case, I want to set the hard constraints to 0 by default, and I want to set the soft constraints. So here, come down here. Yeah, soft constraints, I want to set this to a value of 1. So then when we use the paint tool, we don't have to flood this unnecessarily, and you can see that the hard constraints are now 0 and the soft constraints should be set to 1. So what our solver will do, it will do a normalization internally, which will allow us to just come here and start painting the slide constraints wherever we want. Just be careful in case you paint the hard constraints there, you would have to reduce the hard constraints in the areas where you want soft sliding and soft constraints to appear. But essentially what we want to do now is, let's use, for example, let's start off with a value of 0.7, which is something that may be a bit conservative for the time being. And here, let's just use the symmetry option for the painting. And in this case, we don't have to time shift anything because the input geometry is not animated. So here, let's use, for example, the scapula. That's an area that we do want to simulate. And then we, for example, want to also simulate all of this area right here with sliding, and especially also down here at the back of the character. And here it's very important that we also blur out the results. In this case, you can just use the paint node to blur, but you can also use the attribute blur node from Houdini for this. And yeah, you can also do script-based normalization, but here we just want to show you that you can get some sliding in this way. So here, adding some smoothing to the mix. And now we can come directly onto the ADN skin node. And we are going to just play back and see how this looks. And you will see that you cannot see any sliding happening. And the reason for that is that we have not configured the max sliding distance. So in this case, let's use a unit of 1. So that will be 1 centimeter. And yeah, you can add a sphere as we showed in the crafted tutorial to modulate the range. And now we should start seeing, and if I rewind, how the sliding appears through the mesh. So let's see if the normalization kicked in properly. Let me come here and come here to the slide constraints. And yeah, maybe we do need to increase a bit some of the values. In this case, we are pretty fine. So we are being quite conservative with the sliding. Let me try, for example, a max sliding distance of 2. And yeah, we can compare this, for example, if we say that we template this one and we check out this skin right here. So here, and we have this geometry templated. See, we can see some sliding happening. Yeah, you can see there the mesh is sliding over the skin, but we can maybe exaggerate this a bit further, I think. So let's go back to the slide constraints, and maybe let's use this value 0.9. And this is essentially something that we can refine later on. Let me just try this out quickly to understand if we can get more sliding. Yeah, and as you can see there, it's sliding a bit too much. So yeah, I guess going back to what we had before with a value of around 0.7 is more than enough. Maybe we can increase it a bit further in this area, and then just smoothen it out a bit further. And you can also use the max sliding distance multiplier in case you cannot achieve the right smoothing across the borders to actually limit the regions in which you want to slide. So here, come to ADN skin, reinitialize the system. yeah, and you can start seeing that sliding happening there on the scapula, and that's essentially what we want. And then of course exaggerate it further by playing around with the different parameters on ADN skin, reducing the iterations, the different constraint properties. So for example, here we have the soft constraints, which we can reduce testing to see if reducing those constraints will actually allow you to get better sliding. And then you also have the ability to, for example, control the sliding constraint mode to make it faster to simulate. But yeah, you can see there the sliding appearing. And then you can also add relaxation on top, of course. Great. So now we have ADN skin ready. We will then go back and refine a bit the setup, but essentially I think you get the idea. But now we may want to blend in the results back from the animation into the actual simulation. So blending the simulation with the animation. So what I'm going to do now is I'm going to add an ADN skin merge node. Going to add it right here, and as you can see, this is the time shifted version of the skin without any animation. Okay, so let's bring this down here, and here we're going to do a quick trick to avoid having to paint this all manually. So essentially what we are interested in is, let's go to the ADN skin merge node. Let's make sure that the init time is correct. Then we are going to use as anim skin, we're going to use the one that we have right here. So we can drag and drop this in here. And then as the simulated mesh, we can use the one that we have just prepared right here. Great. So in some cases, we do not really want to, in some cases, we do not want to really paint this manually. So we are going to drop down an attribute transfer node. And what we are going to do is we're going to just bring the actual painting over to the original geometry. Okay, so what I'm going to do is I'm going to come here to the ADN skin merge node. I'm going to copy over the blend weights, so copy parameter. Then I'm going to do an attribute create, and I'm going to paste in this name right here. Oh, sorry. Sorry, this should be this, and paste values. Great, sorry. And now what we want is that we want to actually blend that result using the static mesh that we have cut out. So we want to transfer the weights over to essentially the original stream of data. So what I'm going to do is I can get out for example, the cutout geometry, and this is already time shifted, if I'm not mistaken. Let me see. Yes. So we are creating ADN blend on this mesh. I can set a value of 1. And yeah, you'll see that now if I get this and plug it into the attribute transfer, I can use the point group, and I'm going to transfer over ADN blend. So if I come here now to ADN blend and come to the condition, I can just set the distance threshold to 0. And yeah, in this case, this is maybe a bit too harsh, but then we can use an attribute blur to reduce a bit the cutouts and avoid that kind of harsh cut that you have here between the simulated and non-simulated version of the mesh. So here we have ADN blend as the input, and we can use, I don't know, let's try using 10 iterations of blur iterations, and yeah, that will go into the skin merge solver, which we can reinitialize in a second. And you can see that now everything is working as expected. And yeah, now we can play this back. And this essentially would be the result of simulating, adding dynamics, adding some controlled sliding to the mix. You can see there it's sliding over the scapula compared versus the original vanilla skin cluster, let's say. That doesn't have those properties. It doesn't have that kind of dynamics that we want to achieve. But yeah, here you can really see the dynamics, and just there elasticity also of the skin while simulating. And yeah, so that will be how you can prepare your scene using the crafted workflow. We will go ahead and do some refinements now to the scene just to see what we can do. For example, here we are going to go into the fat layer and do some adjustments. Then show the final result. So after some further refinements, this is the result that we would get out of the hybrid workflow using AdonisFX. So let me just play this back. And you will see that here in this area, we get some sliding over the scapula and in other areas too, which is essentially what we want. And then we also have here, for example, on the neck area, some interesting dynamics, which you can add on top of your non-hero characters or your background characters, just to give it a more lively behavior. Great, so let me go over the changes that we have done since the last video, which has been, we have added here a bone deform for extra geometries, just to be able to visualize this better, with also some geometry that will come with the animation. Then we have just cleaned up a bit the network, added some sticky notes. So let me go from top to bottom. In this case here, just a clarification that this time shifting approach is not strictly necessary. It's actually just to speed up the scene, and the same with the mirroring of the weights. It's just something that we wanted to provide in a different option to show you different workflows that you can integrate here, but you can just use the symmetry option of the attribute paint node. We have also added some small adjustments to the weight maps. So here, for example, let me go to ADN weights and visualize this properly. So in this case, yeah, we added some more weights in some areas just to avoid creases for the relaxation. And yeah, so that is for this weight map. Then for the fat layer, what we've done is we have decreased slightly the amount of iterations, which will actually give us more dynamics on the character. Then for ADN skin, what we have done is that to get a bit more sliding, come here to the slide constraint map, we have actually just slightly flooded the whole mesh within an add mode, which allowed us to get a bit more sliding over the whole character. Then yeah, here for skin merge, we have not done any changes, just small tweaks here and there to improve the results, mainly on some of the maps. And then also at the very end, what we'll have here is, if I pin this, we've added a switch statement, so you can just quickly go through, skim through the different layers. So for example, here we have the fascia layer, and then we have the skin, well, the fat layer, sorry. Then we have the skin layer with all of that sliding. Then we have the rendered skin. We have the rendered skin plus the those extra render geos. We have two streams just to make sure that if we visualize the simulation, we are not getting an impact of bringing in that geometry. And yeah, and then finally we have here the animated skin. Great. So yeah, that should be it for covering everything for the hybrid workflow. You can of course go ahead and also check out the lighting on this final scene. But essentially, yeah, this would cover everything for the hybrid workflow for AdonisFX.